Because I is the square root of a negative 1, when we raise it to different powers, we get actually a pretty cool pattern. Let's look at what it is. I to the 0, I'm going to start with I to the 0. We know anything to the 0 is 1. Anything except for 0, of course. You can't do 0 to the 0. But I is not 0, so I to the 0 is equal to 1. Of course, I to the 1 is equal to I. I squared, from the definition of I, is negative 1. Let's look at I cubed. Well, I cubed is I squared times I. I'm going to write that over here. I squared times I. But I squared is negative 1. So this is negative 1 times I, which is negative I. If I look at I to the 4th, well, I'm going to write over here again. I'm going to split this up. This is I squared times I squared, which is negative 1 times negative 1, which is positive 1. Well, now notice, look, I'm back to where I started. I to the 0 was 1. I to the 4 is 1. Let's do one more. I to the 5, I'm going to think of this as I times I to the 4. But I to the 4 is 1. So this is I times 1, which is I. And you can see here that we've got a pattern, right? The 1 right there, and then I've got an I that repeats. So you can guess that the next one, I to the 6, without doing any work, it should probably be this next thing. It should be negative 1. And it is. So the powers of I, the integer powers of I, has this beautiful pattern. You'll notice that it's every 4, right? That the cycle is every 4 numbers that we go through to start repeating. And what's really awesome is, because of that, we can get any power of I by simply thinking, how many times does 4 go into it? Let me give you a little example. Let's suppose we were to do I to the 63. And what we can do is say, well, instead of actually multiplying I by itself 63 times, what we can do is say, well, how can I get 63 from 4? How many times would I have to, what is the multiply 4 by to get close to 63? Well, the closest I can get to it without passing it up is 4 times 15, which is 60. And then I've got another 3, right? 4 times 16 is 60, plus 3 is 63. And the reason this is helpful is because I can then view this as I to the 4 times 15 times I cubed. And I to the 4, oh, that's not what I wanted. I to the 4 to the 15, I can write it like that, times I cubed. And then I can say, well, I know that I to the 4 is 1. To the 15 times, I know I cubed is negative I. Well, this is just 1 times negative I, which is negative I. Now, the moral of the story here is the only thing that really mattered was this 3 right here, because when I use the 4, I know that I to the 4 is 1, and 1 to anything will be 1. So really, this right here is all that matters, and you'll notice that that number is the remainder when I divide 63 by 4. If I take 63 and divide it by 4, I get 15 with a remainder of 3. Okay, another way we write that is 15 and 3/4, right? There's the remainder 3. So this is a very powerful fact. This tells us that I to any power, any integer power, is equal to I to the remainder when that power is divided by 4.